You can probably guess our goal at this point. It is still to compute the derivative as many functions as possible. And the class that we're looking at this time is compositions. That is, I'm considering things like this, the derivative of sine of x cubed, where you've got an outer function sine and an inner function x cubed. So let's look at compositions in a little bit more detail for a moment. When I look at this sine of x cubed, there's sort of three components to it. First of all, you have this x, the actual variable. And then what it tells us is that there's two sort of embedded function here, that variable x gets cubed. And then whatever the result of that is, you take sine of it. Or another way to sort of think about this is that you can say that you start with the variable, then under the sort of so-called inside function, you cube it and turn it from x to x cubed. And then based on the outside function, you take sine of whatever you had, sine of x cubed. Or more generally, if I'm going to have a f of g of a variable x, that what you're doing is you're starting with this value of x, you are doing the first function, the g, the inside, to make it g of x, and then you're going to go and apply the outside function so you get f of whatever g of x was going to be. So a whole bunch of different functions can be written in this way, where you've sort of got an outer function, that's the sine in this case, and you've got this inner function, that's the x cubed in this case. And you think of it as a composite function. Another way, by the way, notationally to write this f of g of x that you might see is f, this little circular dot means composed, so f composed g of x. And you'll see both f of g of x and f composed g of x. So how do we take the derivative of a composite function? The formula is something referred to as the chain rule. It's going to look a little bit messy. If I'm going to take the derivative, so notice I use the prime here, I put everything in brackets, the derivative of f composed g of x, well, what it is the derivative of the outside evaluated at the inside multiplied by the derivative of the inside. F prime of g of x times g prime of x. That is, what we have is three different components. The first, the f prime, I'll say this is going to be the derivative of the outside function, the derivative of the f. But notice it's the derivative of f at something. Derivative of the f evaluated as g of x. So it's the derivative of the outside evaluated at the inside. And then the third component is times this derivative over here. So this is going to be multiplied by the derivative of the inside. So the chain rule has these sort of three outputs. The derivative of the composition, but it's the derivative of the outside at the inside times the derivative of the inside. Okay, so let's see an example of this. I want to focus on the derivative of sine of x cubed. So my outside function, this is going to be the f. This is just sine of x. And note carefully, when I go and write f of x is sine of x, the x here is just a placeholder. It could be f of 7, f of 17, f of 17 squared, f of 17 cubed. It could be anything. In particular, one option for what the x could be is it could be the entire output g of x. So in other words, f of g of x would be sine of g of x. So when I write down this f of x equal to sine of x, I'm just saying what function is just the f part of it. Likewise, the g of x, that's the inside. This is going to be the x cubed, so g of x is the x value cubed. Okay, so let's apply our formula. So first of all, I had to figure out f prime. Now, the f was sine, and the derivative of sine is cosine. So I'm going to say that this is equal to cosine. Now I got to be careful. You might be tempted to write down cosine of x here, but that's not the case. It's f prime evaluated at g of x. So I'm going to write cosine, and I could have leave a blank. It's cosine of whatever's supposed to go there, whatever the argument is. But in this case, the argument, the g of x, is going to be this x cubed. So I can put that in. They've got my variable, which is my x, and then I'm going to be cubing it. So this is cosine of x cubed. So that gets me to the f prime of the g of x, but I still have the g prime of x. Okay? Now g is this function x cubed. And the derivative of x cubed is 3x squared. So I'm going to come along here and multiply by 3. I'll still leave the variable name in x. So 3x and then squared. So I have my f prime g times my g prime, or the derivative of the outside at the inside times the derivative of the inside.